welcome back to my online teaching platform. In this lesson, we shall learn how to find the derivative of trigonometric functions. We'll be looking at trigonometric functions in terms of sine, cos, and tan. But before we do that, let us know the derivative of sine in this particular video. So we'll be learning how to differentiate the function y is equal to sine x from the first principle. So if I have a function y is equal to sine x, how do we differentiate it? So let us use the first principle to find the derivative of the function y is equal to sine x. So we have our dy dx to be equal to the limit as h approaches 0. We know our first derivative formula, which is f of x plus h minus our f of x divided by the small change in x. All right. So knowing our function y to be sine x, this implies that our f of x will be equal to sine x. All right. So we now need to find our f of x plus h, which implies that whenever you see x, you plug in x plus h. So in our function y is equal to, so we have it to be our f of x plus h to be sine of x plus h. So we are just replacing the x in the angle x with x plus h. All right. So we now plug in the various components. So we have our dy dx will equal to the limit as h approaches 0. Then we have our f of x minus the f of x. So sorry, our f of x plus h minus the f of x. So our f of x is this. So you are going to get sine of x plus h minus sine x. Then all divided by h. All right. Now looking at the numerator, we say we have a compound angle over here. So let us bring down that one. Our compound angle is sine x plus h. So let us expand this. So we know that the identity for sine x plus h is sine x then cos h plus sine h cos x. All right. So this is what we are going to use to replace our sine x plus h. So we have our limit of, so our limit as h approaches 0. Then in place of sine of x plus h, we have this. So it's going to be sine x cos h plus sine h cos x minus sine x. Then all divided by h. All right. Now you will see that we can group like this. We have sine x here. We have another sine x here. So let us rewrite the expression. We have the limit as h approaches 0. Then we have sine x cos h minus sine x. So this sine x is what we have here. So it's now left with this part of the numerator. So we are left with sine h cos x. All right. All divided by h. So we have equal to the limit as h approaches 0. Okay, here we have sine x. So we can factorize sine x out. So when sine x divides sine x cos h, we will be left with cos h. When sine x divides this, we will be left with 1. Then plus we have our sine h cos x over here. Then we can we can divide this one by h, then also this one by h, since they all have the same denominator. All right. So we have the limit as h approaches 0. Then we have sine x multiplying since this sin x is multiplying cos h minus 1 all divided by h, we can divide just one of the factors of the expression by the denominator. So it's going to be cos x multiplying cos, sorry, sin x multiplying cos h minus 1 divided by h, since the h is common to all of them. So the same thing. Then we have here plus sin h also over h, then open bracket cos x. All right. Let us continue. So we have this identity. So now we are going to take the limit. So when you take the limit of, so if you have the limit as h approaches 0 of cos h minus 1 over h, the h can be any number, but because we have h approaching 0, so if you have identity in this form, this is 0. Now another one is if you have the limit as h approaches 0, that is sin h of, sorry, sin h divided by h, the result is equal to 1. So it means we are going to substitute. So we are going to, when you take the limit of this particular expression, you are going to get the result to be 1. So it's going to be everything equal to sin x times 0, then plus sin h over h as h approaches 0 will be equal to 1. And that will multiply cos x. All right. So at the end, you are going to get sin x times 0. I think here will be 0, then plus cos x. So we are going to get the result to be cos x. All right. So this implies that our dy dx is equal to cos x. So we can conclude that whenever you differentiate, sin x with respect to x, you are going to get cos x. But in differentiate, suppose you have sin theta, and differentiate with respect to theta, there's no way you bring x again. So it's going to be d sin theta over d theta. So that will give us cos what? Theta. All right. So anytime you differentiate sin x, you get cos x. When you differentiate sin theta, you get cos theta. We are going to apply this concept when we are differentiating complex trigonometric functions. All right. So in the next video, we shall look at how to differentiate sin x. We shall learn how to differentiate sin x. Then after that, we'll also look at how to differentiate tan x. All right. Thank you for watching. Bye.